All right, good morning. Today we're taking on a little review of surface area and volume. So this is our review, the first part of it. So here we are taking on a cylinder to start. And I'm saying find each of the following for the solids. So I want surface area, I want volume as well. But we know that the first thing that we always have to do in these problems is focus on the base shape. So here is my base. I know it's a circle. And I'm given that that portion of it is 12. So here's my overhead view of it. What I should notice is that this is a radius and this is a radius right here. So I actually have a 45, 45, 90 triangle, an isosceles right triangle. So then, when I can see it as an isosceles right triangle, let me write that. Right, or a 45, 45, 90 triangle. We know that the two short legs are the x, and the hypotenuse is the x root 2. So that little shortcut that I've been teaching you is to take half of the 12 and multiply by root 2. So I'm going to get 6 root 2 here and 6 root 2 here. Okay, which really tells me my radius value, which is essential to the problem, my radius value will be 6 root 2. All right, so my base shape is a circle. My radius is 6 root 2. I know that if I wanted just one base area, it would be pi r squared. So we're going to see that show up when we solve for surface area and volume in just a moment. So let's start with surface area. So surface area. So our surface area, we know that it is a cylinder. So we're looking at a cylinder here. We have our two bases. They're both circles. And then we have that curved lateral face, just one of them. So we're looking at the circumference times the height. That's the curved lateral face, the lateral area, plus our two base areas. So 2 pi r squared, both circles. Okay, and then we're going to need the volume too. So let me write that out over here. So we know that that's the base area times the height. So the base is a circle, pi r squared, times the height, like that. So I'm going to plug in for the radius, the 6 root 2. I'm going to plug it in everywhere I see the r. And then my height is 26. All right, so looking over here at surface area, I'm taking 2 times 6, so 12 times 26, and I get 312. And then the pi, and then the square root of 2. Okay, and then over here, if I take 6 root 2 times 6 root 2, that's like saying 6 times 6 times 2. So I have 72. And then times 2 is going to be 144 pi. Okay, those are not like terms. There's nothing else I can do to consolidate. So that's my surface area. So 312 pi root 2 plus 144 pi and units squared because we're talking about area. So always units squared with area. Okay, volume. Here, 6 root 2 squared is like saying 6 times 6 times 2. So 72 times 26 gets me 1,872 pi. And then units cubed because we're talking about volume. So volume is always units cubed. All right, next up, here we're looking at a cube. So perfect cube because all sides are the same, right? Our length, our width, our height are all going to be 4x. There's my cube. Okay. So first I want the diagonal. So my diagonal, let's do it up here. So my diagonal will be the square root of length squared plus width squared plus height squared. So all of those sides, the length, width, the height, they're all 4x. So I'm looking at 4x squared plus 4x as a quantity squared plus 4x as a quantity squared. So it's always the 4x inside of parentheses being squared. So now it's really an algebra problem from this point on. So I can distribute that exponent of 2 to both of my items inside of the parentheses. So in my next stage, I really have 16x squared 3 times. And since those are all like terms, I can combine them underneath the same radical and get 48x squared. So now I'm simplifying. So I'm thinking of, well, 48 is 16 times 3, so I'm going to have a 4 on the outside. And I know I'll have the 3 underneath, right? Square root of 48 would be 4 root 3. And I also have a pair of x's, so I have an x on the outside as well. So this will simplify to be 4x times the square root of 3. And then whatever units we're talking about. Okay, and then surface area, I'll tuck that in right here, surface area. It's a cube, so all of my faces are perfect squares, and I have 6 of them. So 6 times a side squared, so 6 times 4x as a quantity squared. Okay, so here I have 6 times 16x squared, just like that. Okay, which then will become 96x squared unit squared. So 96x squared unit squared. Okay, volume. So volume is just a side cubed. So I'll say S for a side cubed. And I'm just plugging in a 4x, raising it to the 3rd power. So 4 cubed would be 64, and then x cubed, and then units cubed. So 64x cubed, units cubed would be my final answer for volume. Okay, let me push up to the next one right here. So now we have a cone. Here's my beautiful 3D cone right here. All right, so here we are given the slant height. So let me just make a note of that. That's the slant height. I need the radius. I'm going to need the height as well. So I'm also told that the circumference of the base is 12 pi. That's crucial. Circumference is 12 pi. I know that the circumference is 2 pi r. So I can usually just see from right there that my radius has to be 6. But let's say you weren't sure. You could always build an equation, 2 pi r equals 12 pi, and divide each side by 2 pi. That confirms it. My radius is 6. So that's 6. That's my radius. So now I could use Pythagorean theorem to find my height, but I should recognize that this is a common Pythagorean triple. It's really a 3, 4, 5, but times 2. So all of those sides have doubled. It's a 6, 8, 10. Okay, again, if you didn't see that, that's not a problem. You could still use Pythagorean theorem. So my height ends up being 8. I'm just trying to show you a little shortcut to get there. So now I have everything that I need. So let's do surface area first. So surface area, it's a cone. So that curved lateral face, right, that sector is pi r slant height. And then we know that the one base is a circle, so pi r squared. Volume would be a third of what it would be as a cylinder, so 1/3 base area, pi r squared, times the height. So when I plug in my radius is 6, so I'm going to plug in a 6 for each radius. My slant height is 10, and my height is 8. So I'm just multiplying across. 6 times 10 is 60, so I have 60 pi. 6 squared is 36, so 36 pi gets me 96 pi. So my surface area is 96 pi units squared. Okay, my volume here, if I'm taking 1/3 of 36, I now have 12, and then times it by 8, and I have 96 pi here as well. So I ended up getting the same number, but I just got to remind you that they represent totally different things, right? The surface area is like the wrapping paper that it would take to cover my shape entirely, and the volume would be the number of unit cubes that would fill up my figure entirely, right? The visual I keep giving you is like a fish tank that's being filled with water. So that would be like volume. All right, on to 4. So for here we have a triangular prism. Let me see if I have a model for that. I do, of course. So here's my triangular prism, and my base shape is an equilateral triangle. So let's focus on that base first, because that's crucial here. So here's my base shape, an equilateral triangle. I'm told that a base edge is 12, so all my sides are 12. Okay, and if I want its area, I could do 1/2 apothem times perimeter, or I could do 1/2 base times height. It really doesn't matter here, so I'll just do 1/2 base times height. Since all sides are 12, my base has to be 12. And I know that for any equilateral triangle, it splits right down the middle and makes two 30, 60, 90 triangles. So here's my 60, here's my 30, here's a 30, here's a 60. So we know that here is the x, here is the x root 3, and here's the 2x. So that means that this part right here would be 6, and that height that I wanted is 6 root 3. Okay, so I'm going to plug in a 6 root 3 right here for the height. Half of 12 is 6. 6 times 6 is 36 root 3 units squared. Okay, absolutely crucial with the prisms to have the right base area, because if we don't, right, we're gonna get a surface area that's wrong. We're gonna get a volume that's wrong also. Okay, so now building off of that. So surface area. So for the prism, that lateral face, the lateral area, right, when I view it flat, when I view it as a net, I picture it as a big rectangle. So I'm looking at the height of the prism times the perimeter of its base. That gets me my lateral area, right? Flat looks like a rectangle. And then I add the two base areas. Volume is base area times the height. So for this one, the height of the prism is 18. The perimeter of its base, well, I have 12 times 3, so 36. Perimeter is 36. My base area is 36 root 3. Okay, so over here, I'm just going to plug it in, but crunch it in a second. So base area is 36 root 3, and the height is 18. So if I'm looking at surface area first, 18 times 36 gets me 648. And then my two base areas, I get 72 root 3. So 648 plus 72 root 3 units squared for the surface area. And volume, 36 times 18, 648. And then root 3. So 648 root 3 units cubed. All right, two more. Okay, in 5, here we are given a pyramid, a right pyramid, with the base that's a regular hexagon and the base edge all 10. And here I'm just making sure that you know that it's not to scale. So first up, let's just draw out our base shape. We know that that is crucial. So it's a regular hexagon. And we're told that base edge is 10. So let me draw in my apothem and my radius just like so. So when it's a regular hexagon, we know that it splits in two. Here, a 30, 60, 90. Here's 60, here's 30. Here's x root 3. So we know that this part right here, half of a side, is 5, and the apothem is 5 root 3. So if I'm looking for my base area first, area is 1/2 the apothem times the perimeter. So I'm looking at half of 5 root 3 times a perimeter of 60. So if I take half of 60, that's 30 times 5 gets me 300. And then, let's see, I think I did that wrong. Half of 60 is 30. 30 times 5 is 150. There we go. 150 root 3 units squared would be my base area. So I'm just looking at that part first, because I know that, again, I need to get that part correct in order to get surface area and volume correct too. Okay, the other thing that I know before I push forward is that I have this right triangle relationship. So here I know that I have, if I try to find here, so if I look at the middle of this side like that, and I draw in here, that would be an apithumb, and then here would be my slant height. That would be one of the right triangles that we keep talking about that exists inside of every right pyramid when we have a regular base. So if I look at that triangle off to the side, we know that this is the height, this is the apithumb, this is the slant height right there. So we know that the height is 5. We solve for the apithumb over here. The apithumb was 5 root 3. So here I could use Pythagorean theorem to get there, but I might also recognize that this is a 30, 60, 90 pattern, and again, not to scale. But I can see that this leg is x, this leg is x times the square root of 3, so here my slant height has to be my 2x, so my slant height has to be 10 right there. So now I know everything that I need. I have my height, I have my apithumb, I have my slant height, so now I'm going to get my surface area and my volume. So surface area I'll do down here. So here I know it's a pyramid, so I know it's going to be 1/2 the slant height times the perimeter. That takes care of all of those triangular lateral faces. 1/2 the slant height times the perimeter, and then I have one base area. Okay, happens to be a regular hexagon. And then volume is going to be 1/3 of what it would look like with the same base shape and height as a prism. So 1/3 the base area times the height. So I'm plugging in a slant height of 10. The perimeter of the base is 60, and the base area is 150 root 3. I'm going to plug it in over here as well. Base area 150 root 3, and the height of the pyramid is 5. So if I multiply across right here, I'm taking 1/2 times 10, so 5 times 60, I get 300, plus that base area that's 150 root 3. So surface area is 300 plus 150 root 3 units squared. Okay, volume, 1/3 of 150 is 50. 50 times 5 is 250. So I get 250 root 3. So 250 root 3 units cubed. All right, so lastly, looking at 6. So here we're told that a cross-section has an area of 49 pi square units, and we're looking at a sphere. So here is a model of a sphere. So here we know that if that's a cross-section, if that's this cross-section right here, for example, through our sphere, that area of 49 pi will lead us to our radius, because we know that an area is pi r squared. So I should be able to see that the radius is 7, but in case you can't, you can set your equation like this, where pi r squared is equal to 49 pi. We can divide each side by pi, so the radius squared equals 49. Take the square root of each side. We know that that means it could be plus or minus 7, but has to be the positive 7 because it's a measurement, it's our radius. So once we have our radius, now we can go and look at surface area and volume. So surface area, we have 4 of those cross sections, so 4 pi r squared, and then volume, 4/3 pi r cubed. So I just need to plug in that radius of 7. It's one of our easier formulas. So 4 times 7 squared, so 4 times 49 gets us 196 pi. So surface area is 196 pi units squared. And then volume, I'm taking 7 cubed and then multiplying by 4/3. So I would get 1,372 pi over 3. So 1,372 pi over 3 units cubed. If you left that mixed, that would be fine. You could write that as 457 1/3 pi units cubed. That would be fine as well. What I don't like to see is I don't like to see something that's rounded with something exact. So you want to be careful about that because leaving the pi in there is leaving it exact. So when you start to round, for example, if you wrote this as 457.33, that's giving me something rounded with something exact. So leaving it as a fraction, right, that's leaving this exact. You're leaving it nice and precise, and we always appreciate precision. All right, we are good with our review today. I tried to look at each of the solids that we've been dealing with, just to review them all and practice using their formulas and solving for those pieces of information that were not explicitly stated. All right, have a good rest of your day.